Hello, friends. Glad to see you today in Young Learners Bollineni Hillside Play School. Those who has not been able to come today, for them I am recording this and hope to see you on the next session. Or if you have any doubt before that, please let me know. So here it is. So this is the slide today I presented. You can see it's electronics, robotics, AI, gaming, programming. And what brings you here is the passion and creativity. Let's go forward. So safety first, right? So there are shouldering and other things, but I don't prefer you to do that. So in the class, we will use the temporary connections and not the permanent shouldering. They have lead poisoning and many other burn wounds and many other hazards. So we don't like to do that. And moving to the next, we'll be using some electronics kits to make you understand Ohm's law and many other basics of electronics, which is like resistance, voltage, current. Without that, you cannot proceed further. Okay, so next. So mostly the programming that you'll be using, I'm talking about the age 6 to 7, 8, 9 ish. Mostly you will be doing the block coding. So you see, it's a fun coding. You don't have to really write or type coding, but it will do a lots of thing that the programmer will struggle to do. You'll be making games and you'll be interacting with robots. You can move. You can see in the next slide what I'm talking about. So not only moving these characters, you can also move these robots like you see. So all this thing is possible by block coding, and also this smart street light is one of the Hello World project we say in Arduino or in robotics. Moving to the next. So this is the AI coding. So using the same block coding, you can even do the AI game. Like you see this Flappy Bird. So this Flappy Bird, she is moving the bird and saving it from the pipe using her nose. So how it's detecting the nose? Is the AI trained model. So it's already trained. You don't have to worry about how to train it. If you want to worry about, I'll be very happy. I will show you how to train a model to detect nose, hand, and all these things. You can see the mask. It can detect you are wearing a mask or not. You are sad or not. Your hand it can detect, and that particular character is moving. Okay, coming to the next. Here we see another block coding example. What is driven a handheld bit, sorry, it's called microbit. This is the microbit. So this handheld microbit device, and you created a shooting star game. So this enemy is shooting star and you are saving yourself by just pressing the physical left and right buttons. And then you have a bat killing game, and then you have this apple catch game. And see, the code is so colorful and so small. So it's very easy to design, and you'll be really feeling of accomplishment. So that's one thing. And then this is some other projects. You can see RFID project, and then sorry, I want to move to the previous page. Yeah, so this RFID project, and then line following robot, and then so these are some easy projects. You can think about what are the different things you can make. So you are not only bound by what you see here. This is just for some examples, just to encourage you. And this is a remote control car, and one AI application you can see here, which is seeing your hand gesture and doing things. Okay, and moving to the next. So yeah, other than robotics, you also have to know how to debug your things. Suppose you made a robot today and tomorrow it's not working. Are you going to throw it away? No. The debugging is the first thing in the developers that makes it different from the other developers. Yeah, so debugging is one of the important thing you should know. And coming to the next, what is the next important thing that many developers, many like courses that you will be attending in robotics will be missing this. So that's what I'm asking you. So you see, you go to a coffee shop, local coffee shop versus a Starbucks or cafe coffee day, CCD. What's the difference you see? Other than that, I'm not pointing out the other difference, but I'm interested about the consistency. You go to any branch of Starbucks, you will get the same kind of coffee, and that's how it's possible. How it's possible? It's called calibrations. So you have to calibrate in the two identical thing in the world doesn't behaves identically. There will be some small change, and you have to count it, you have to balance it, and you have to make it work similarly despite of the fact they are not similar. So the outer world will not understand, will not feel that they are different things. They will feel both same, and that's what they have done. It's a more abstract way I told, but you can go to the details. But that's the calibration. After debugging, calibration is another important thing that you should know. And coming to the theory is boring, right? Yeah, I also agree. But I have found out many interesting things that will make it really interesting, fun, engaging, and you'll be really liking it. And you must like it, because if you don't know the theory, how you will make the next project? I will help you in making 1, 2, 3, 4 some projects. But once you come out of the project, out of the coaching class, then you go to the YouTube and you see many other projects are there in the world, and you might be thinking something of your own. You want to make those projects, but how can you make that if you are just concentrated about what I am telling you and what you are doing? So if you have to know the basic, you have to know the theory, then you can think of your own, you can come up with your new project. Suppose you have never worked with some particular sensor, but if you know the concept without working with the sensor, you can tell, okay, my tomorrow's I am thinking about a project. I never use the sensor that it needs in that project, but still I know, I am confident that I can use this. That's confident I'm going to bring within you. So coming to the next, there's a joke, and if you don't know numbering system or binary, you may not laugh at it, but I am guaranteeing you that after going through the course, once you go through the number system, you will definitely laugh at this joke. Okay. And then became in best known methods. So because I work in IT, I work in a company. They makes semiconductor some device for semiconductor inspection. It's, you can tell, electron microscope kind of thing. So being in an industry for past 13-14 years, I know how to present your idea to the bigger crowd, how to make it more acceptable. Those ideas, those block diagrams, black box diagram, and many other concepts are there. I will teach you those things, how to express yourself. So these are another bonus thing you're going to get from me. Coming to the next, so these are some histories. So you should know what you see today is why it is so. You see today, computer don't understand anything other than 0 and 1, but why it is like that? In the early days, how the computer used to look like, what are the challenges they faced and that we overcome now, and still what are the challenges we have. In future, suddenly a different kind of computer will come, and then you will be surprised, like whatever I learned, everything is has no value because it's something new came up. That's not going to happen, because you should know the concept. You will predict, you can suspect something is going to come. That's what the beauty of the theory, beauty of the history. Coming to the next, here is another example of Internet of Things. You might be already knowing IoT. So this one, using this, you can operate all of your home appliances, devices remotely. Okay, so IoT is something that also part of the robotics. Once you learn how to do the block programming and how to what is the electronics part of the robotics, and then you will be able to understand what the IoT, how it works. Also, you have to know how the web, how the server web programming, a little bit of that, and then you will understand how we can access out of the house. But while doing the IoT project, you might feel the block programming is little laggy. You have to draw so many drag so many blocks into the screen to achieve a small thing, and you will feel like, okay, it looks like a block programming is not for me now. When I understood the block programming, now I feel like something more powerful could be there. And then you can tell, okay, dear code, don't have to hide, you can come behind the block programming. So the block programming is actually not a programming, it's a helper. It's helping you to not to write the code, he's writing the code behind you. And when you are saying that I'm comfortable with the code behind you, then the Python comes out, because that's the code running behind the block programming. Then we learn Python. Once you learn Python, you'll be feeling so powerful. You will feel like, okay, whatever I was doing in the block programming, it was like it's a child act, it's just a childish. But yeah, it's very important at that age. It's really I appreciate that. And then you will be into the Python thing, and then you will know the power of Python, not only in robotics, in many other field, AI and all these things. Then, you know what is running behind Python? It's C++, C. So you might be interested on learning the C and C++. That's also we can go through, but it's okay. Let's go slow, okay? Python, let's understand Python. That's enough for your age. If you are interested, I'm always there for you. Okay, so just to tell what is there behind and behind and behind the C and next till the end, just to give an idea. Don't worry about that. There's a assembly and language behind C. This looks like this, and finally computer understands 0 and 1, nothing else. So finally we're actually hiding this 0 and 1 from you so that you can write a good code coming. Okay, so then behind the scene there is no program. Finally it's a physical world which is made of logic gates, and the logic gates are made of transistors. Same, the silicon sand. So finally, can you imagine one handful of sand is converting into an iPhone in your hand or the laptop. So any electronics device finally in our days is coming from a handful of sand. It's more pure sand. So it's not the sand you get in the beach side. But yeah, don't get frustrated seeing the whole level. Let's go slowly. For your age, block programming, Python, enough. After that, C++, C will be good to know. We'll see for your age, and whatever you're comfortable, we'll go through. Okay, so this is something about me. You can go through. I'm not going to tell. And then this is the certification I did. Stempedia. They makes the block programming software that I'm using. The PictoBlocks, and I got the best performer award. Like top 10 people got this. That's one thing. And my students' achievement. If I show you, Apsara from PSBB Millennium. This year she got second prize on the Agastya Science Fair with blind person, the spec with sensor that can detect something in front of you and save the blind person by a buzzer sound. So something like that. Okay, and then moving to the next, something unique what I made. So there are if you know persistent of view display, some LEDs, if it moves like a fan, and then suddenly a letter will come out, but the letter is actually not there. So that's a POV. Okay, and then you see the Magnum car, it can go any directions. We'll see all the demos. I have this working model. The POV I dismantled, and this is something I'm currently making. This is something on the okay, we'll discuss later. Okay, 6. And what is for you? So you can try many things. I have many things I haven't tried, but I'm confident that it is possible. Even if it is not possible, the failure will also teach you. But you will know that what I'm talking about, and you will also feel confident. You will also add more blocks into this unique idea bucket. I will explain you all these new ideas that is coming in my mind, but I haven't never tested. Okay, so moving to next, how to get maximum out of my course. You being student, don't feel shy of what your friends are thinking. Ask me questions, lots of questions. Tell your parents what you learn in your school today. If you have siblings, teach them. And finally, I am requesting feedback from your parents. If they see really you are learning something, or you tell parents, if you are not able to tell me directly that what could have been done better, I can I'll be really happy. I'll definitely consider it. The methodology, teaching methodology that I use. Okay, so we'll see some teaching methodology, some practical analogy we'll use, like the voltage, current, and all. It is analogous to a bucket of water flowing through a pipe, and how it is analogous, how the resistance is represented in this story. So we'll see. It will be interesting. Okay, and then don't lose relevance. You should be always in relevant. You should ask always to me why you are teaching this, why I'm learning this topic in robotics. I'll answer you. I'll be happy to answer. So always be in the bigger picture. If you're into any of the specialized thing, anything too much involved into, and you might feel like, okay, I'm getting demotivated, something theory or something you'll keep on learning, and you don't know the application. You might get demotivated. You can tell me why I'm learning this, and then this is what comes. You have to be like this eagle. You should see from the top view. You can see the bigger picture. I will help you that there, and then you will understand that smaller thing you're into, the particular thing you went in depth to understand more. You will understand the bigger picture, and it will make more sense to you, and that's I'm going to help you. And then intuition of learning. So you learn so many things, math and all of this thing. You know the equations, but do you know what this equation means? What really the equations used in practical life, or when you apply the equations, then what really happens to the function? This is just an example. Many other way you can imagine things. So that imagination is very important. Visualization is very important. That will give you more clue about what can be improved. You can come up with a radically different idea, and those all possible if once you visualize. If you know Einstein, the great scientist, does thought experiments. It's one of the key of thought experiment visualization. And these are some powerful tool I will teach you. These are the experts, and I follow them. So yeah, you might be knowing them. Yeah, that's the end of my show. Thank you so much for listening to me, and hope you will contact me or sir to know more about the courses. I will keep you posted. Keep in touch. Thank you so much. Bye.